In this tutorial, I want to show you how to find the equation of a line to show the relationship between a dependent variable and an independent variable if you have a linear graph. So here's a graph of position versus time squared that is linear. Position is in meters, time squared is in seconds squared. We're going to do the equation of a line, which is in the form of y equals mx plus b. But instead of y and m and x and b, we're going to use the variables and the values that we have from our particular graph. So in place of y, we'll use x, and in place of the slope, we'll use the rise over run. Rise is the change in the dependent variable, or the variable on the vertical axis. Run is the change in the independent variable, or the variable on the horizontal axis. In our case, the rise is 25 minus 5, which gives 20 meters. Always include the units when you do rise over run. The run is the change in time squared, which is 100 minus 0, which results in 100 seconds squared. Putting that all together in the fraction rise over run gives us 20 meters divided by 100 seconds squared, which results in 0.2 meters per second squared. This whole thing is the slope, including the units. In place of the x variable in y equals mx plus b, we'll use the variable on the horizontal axis, which is time squared. In place of the y-intercept, we'll use the value, including units, of the y-intercept. So let's put it all together. So the x comes from the dependent variable, equals the slope, which in our case is 0.2 meters per second squared, times the independent variable, which is t squared, plus the y-intercept, which is 5 meters. So that's the end result for how the two variables in this graph, position and time squared, are related. I hope this helps. Until next time.